What if the world's vast supply of new steel didn't come from deep underground, but from millions of crushed old cars? In the US alone, over 12 million vehicles are dismantled and recycled each year, fueling a global industry worth more than $60 billion. It's not just about saving metal. This process recovers 75% of a car's weight and cuts energy use by nearly 3/4 compared to mining new ore. Yet behind every recycled car, there's a critical first step, one that keeps hidden dangers in check and unlocks this enormous value stream. Just how do these forgotten machines become society's most important raw material? Every year, more than 12 million vehicles in the United States reach the end of their road life. Each one enters a supply chain that stretches across continents and generates over $60 billion in global economic value. This is not a fringe industry. It's one of the largest recycling operations on the planet, employing hundreds of thousands and providing a steady stream of raw materials to steel mills, manufacturers, and construction sites. On average, about 75% of every car's weight is recovered and put back to work, mostly as steel, aluminum, copper, and plastics. That means for every ton of recycled steel, nearly 3/4 of the energy needed for traditional iron ore mining is saved. The result is a dramatic cut in greenhouse gas emissions, less pressure on landfills, and a reliable domestic source of critical materials. In the US, 95% of all end-of-life vehicles are recycled, making cars the most recycled consumer product in the country. This network of scrapyards, processors, and mills doesn't just keep old cars from piling up in junkyards. It transforms them into the backbone of new buildings, bridges, and even the next generation of vehicles. The scale is massive, the impact is undeniable, and the process begins with a single methodical step: intake and inspection. Inside the intake bay, every arriving vehicle is met by the operations manager and a team of technicians. The process is exacting. Each car's vehicle identification number is scanned and logged, its condition photographed from every angle, and all paperwork uploaded into a digital manifest. This creates a permanent record, tracking every step from arrival to final recycling. The inspection doesn't just catalog the car, it assesses which components can be salvaged for resale and which will move on for dismantling. Before any metal is touched, safety comes first. The battery, still holding a charge even after years on the road, is removed immediately by a certified battery safety lead. For conventional cars, the lead-acid battery is separated and set aside. Nearly 98% of its contents, lead, plastic, and acid, will be recycled, making it one of the most efficiently reclaimed products in the world. For hybrids and electric vehicles, the process is even more stringent. Large lithium-ion packs are carefully disconnected, checked for damage, and sealed in UN-approved containers designed to prevent fires or leaks. These containers, lined with fire suppressant and temperature monitoring, are sent to specialized facilities for further processing. With the battery cleared, the car is lifted and secured for fluid extraction. Hydraulic probes pierce the fuel tank and engine, drawing out gasoline, oil, brake fluid, coolant, and refrigerant. Each liquid is directed into closed-loop reservoirs, filtered, and reused to power equipment within the plant. This step neutralizes the last major hazards, ensuring the shell is safe for the heavy machinery and workers who will take it apart piece by piece. The next phase unfolds on the dismantling line, where hands and tools still matter as much as machines. Here, the work is managed by family-run yards, like the one owned by the Cohens, who have spent decades balancing tradition with the demands of a modern industry. The first to come off are the wheels. Each tire, once destined for a landfill, is now shredded and reborn as playground surfaces, athletic fields, or ground into crumb rubber for highway asphalt. A single mile of road can contain the remnants of thousands of old tires. Steel and aluminum rims are separated for remelting, their value tracked down to the kilogram. Windshields and windows follow, cut out with specialized wire saws. Laminated glass is peeled away from its PVB interlayer, a process that recovers up to 80% of the plastic for use in insulation, carpet backing, or soundproofing materials. Doors, dashboards, and seats are stripped, their plastics and fabrics sorted for recycling or energy recovery. Engines and transmissions are either refurbished for resale or broken down for their metals. Catalytic converters, rich in platinum and palladium, are carefully logged and tracked, an extra step made necessary by a surge in thefts and black market sales. Throughout the process, safety is paramount. Workers face risks from sharp metal, toxic dust, and heavy lifting. Protective gear and strict protocols are non-negotiable, a lesson learned from accidents that have reshaped industry standards. By the end of this stage, what once looked like a car is now a collection of sorted modules, each ready for the next round of transformation. Steel jaws clamp down with a force of up to 200 tons, flattening what remains of each car into dense, uniform shapes. The hydraulic press doesn't just crush, it transforms a tangled shell into a compact block, ready for the next phase. Each cycle takes less than a minute. Modern balers, running at full speed, can process between 25 and 40 cars every hour. This is industrial choreography at its most efficient. Baling is like packing goods tightly for storage, while flattening rolls the car into a thin sheet, and shearing chops it into manageable sections. Every method is designed to maximize transport and minimize wasted space, turning bulky scrap into standardized feedstock for the shredder. The result is a yard filled with neat stacks of cubes and sheets, each one a compressed record of thousands of miles on the road. By reducing volume, these machines slash shipping costs and ensure a steady, predictable flow into the heart of the recycling line, where the true liberation of raw materials will begin. Inside the shredder hall, the real transformation begins. Here, compressed car bodies are fed into machines the size of small houses, each armed with spinning steel hammers and teeth. Modern mega shredders process up to 150 tons of scrap every hour, enough to reduce hundreds of cars to fragments in a single shift. With each cycle, the roar of metal on metal signals the separation of decades-old steel from tangled wires, plastics, and glass. Powerful magnets sweep the conveyor, pulling out ferrous metals in seconds. Aluminum and copper, too light for magnets, are captured by eddy current separators that use rapidly changing magnetic fields to launch non-ferrous metals into their own bins. What's left behind is a complex mixture known as automobile shredder residue, or ASR. This fluff, made up of plastics, foam, glass, and dust, is more than an afterthought. It's a persistent challenge. ASR piles can self-ignite without warning, fueled by trapped hydrocarbons and low moisture content. Fires have forced evacuations and multi-million-dollar cleanups at sites from New Jersey to the UK. Even as the steel moves on to the furnace, the unresolved question of what to do with the residue lingers, casting a shadow over the industry's progress. In the heart of the steel mill, mountains of shredded scrap are fed into the electric arc furnace. Graphite electrodes, each as thick as a tree trunk, plunge down and unleash a torrent of electricity, tens of thousands of amps arcing through the metal. Within moments, temperatures soar past 1,600 degrees Celsius. The roar is deafening, the glare almost blinding, as old car bodies dissolve into a river of molten steel. Impurities rise to the surface as slag, skimmed away to leave a pure, glowing pool beneath. This is the point where the past is erased and new steel is born. Some of the world's most advanced mills now run these furnaces entirely on renewable power, pushing toward a future where recycled steel is made with almost no carbon emissions. In Sweden, hydrogen-based furnaces are already producing fossil-free steel, while plants in Germany and the US test new combinations of green electricity and closed-loop systems. At the same time, Digital platforms track every batch from scrapyard to finished product, using blockchain to certify recycled content and carbon footprint. With each innovation, the line between waste and resource blurs further, and the promise of a truly circular economy comes closer to reality. Every year, over 12 million vehicles in the United States alone are dismantled, stripped of hazardous materials, and transformed into new steel. This process recovers up to 75% of a car's weight, saves about 74% of the energy required to produce steel from raw ore, and supports a global recycling market valued at $60 billion. Innovations like electric arc furnaces and high-efficiency shredders have made car recycling one of the most advanced and effective resource loops in modern industry. Yet, not all questions are settled. The safe handling of electric vehicle batteries and the final fate of automotive shredder residue remain ongoing challenges, with regulatory guidelines and new technologies still developing. Today, recycled car steel is used in skyscrapers, bridges, and new vehicles, dramatically reducing landfill waste and emissions. According to the Institute of Scrap Recycling Industries, cars are now the most recycled consumer product in the world. The evidence shows that through disciplined recycling, the vehicles of yesterday are helping to build the infrastructure of tomorrow.